Thank you very much. I'm excited to be here to talk to you all about a topic that is near and dear to me, has been near and dear to Arista since the company was started. My name is Hugh Holbrook. I'm the Vice President of Software Engineering. I've been at Arista since the company was in Ken's living room. And merchant silicon and software have been very, very deep to the company and deep to me for a long time. So I'm excited to talk to you all about this. So we have just not too many topics I want to talk about in merchant silicon. I'm going to talk about our portfolio, a little bit about merchant silicon, and then how that intersects with service provider networks. So this picture here is kind of a little graphic of the different families of products that Arista has. For people who don't know Arista's portfolio all that well, we have small products, large products, products built on different families of silicon, chassis, fixed config devices, all the way from like 21 RU down to 1 RU, 1 gig up to 400 gig. All of these products, some of them are high function, deep buffers, some of them are lean and mean and fast. We'll talk more about this. All of these actually end up being applicable to our service provider customers. They have lots of use cases and they use everything, as we'll talk about. So this picture, actually, I want to throw it up here to sort of set some context. This is kind of a scatter plot of merchant silicon over the last 10 years that we've used at Arista. So this is all the merchant silicon flavors of things that we have used in our products. And what you see here, as you can see in the last 10 years, we've developed new products based on at least 5 different silicon families from Broadcom, Intel, Marvell. And you can see here that there are different kind of trajectories. If you plot out the colors correspond to a single chip family, and they end up with different curves. And so, like, some of them are going, this is bandwidth plotted against time here, just looking at one dimension, which is bandwidth. But one thing you can see here is that different chip families are making different design decisions and going faster or slower. And the decisions can be fairly significant. So, like, between one family and another, at the same point in time, you can have like a 2x performance difference in terms of what the silicon is delivering. And similarly, at the same performance point, one family can be 12 to 24 months behind another family. So they all eventually catch up, and you know, every family is going to get to 3.2 and 12.8 terabits, but at different times. And that's because of different trade-offs that they're making. And I'll talk more about that and how that's relevant to our service provider customers. So this is our routing products. That's based on one of those families that I talked about, is the gray dots. I didn't have the line in there, but it was the gray dots, which is the Jericho family, or the DNX Silicon. And this is silicon that is based on, we've been using it since 2008, I think, or 2006. Really, we started working with this team, but it's really great silicon, and it's got deep buffers, large tables, advanced traffic management. We've invested a lot in protocols. I'm not going to go through the sort of alphabet soup of words here, but it's a significant portfolio of features. And this is sort of the classic service provider routing use cases are based on these systems. And we've got chassis, fixed configs, and it's a 7800, 7500, and 7280 line. And all of this is one EOS image that ships it. It's one EOS image, not just on this family, but across all the families of Arista products. And as a result, we get consistent features in the family and across EOS from the lowest speed up to the highest speed, and from the smallest config up to the highest config. And that's really helpful for our service provider customers that have a lot of use cases. Okay, so that sort of sets the stage on Arista and our products. And now I'm going to talk a little bit about merchant silicon. So first of all, like, you probably know this, but just I'll set out what I mean by merchant silicon, and it's pretty simple. It's chips, usually like ASICs, or I think in all cases it's ASICs, that are sold on the open market, and they're not tied to a specific vendor that's selling the product. And they're not proprietary to that vendor, and they're not tied by a vendor, so no lock-in or tie-in to a specific vendor with merchant silicon. And so that's what I mean by it. So this is like Broadcom, Intel, Marvell. There's lots of startups out there. Many of the startups have been since acquired by Broadcom, Intel, and Marvell, but there's more coming all the time, and a tremendous amount of competition and innovation in this space. So one thing that I want I want to kind of make a point about that I hope is clear, but I won't want to belabor it a little bit, is that all chip makers have access to the same technology. Proprietary silicon, custom silicon, merchant silicon, it's all using the same fabs, the same processes. It's going to TSMC and Intel and Samsung, the same processes, the same memories, TCAM, SerDes. As a result, you have roughly the same clock rates that you can achieve in any process technology. And so, like, where do the differences come from, given that, like, everybody's playing kind of in the same sandbox? And the differences arise primarily because of design trade-offs that are made to sort of focus on or optimize for different use cases. And process shifts. So this is a huge thing, and you know, if you read anything in the trade press, you know about TSMC and TSMC's advancing, and the fact that the M1 chips were built on, you know, TSMC's 5 nanometer process, and they're talking about 3 nanometer and 2 nanometer. But the process shifts going from 28 to 16 to 7 to 5, which is kind of where the networking industry is at, have huge savings because this is the feature size in the transistors, and you can pack many, many more transistors into kind of a fixed die size. And so, like, what was 28 nanometers now in 16 nanometers only uses a quarter of the space, and in 7 nanometers use half of that again, and then 5 nanometers using like half of that again. So you're like tremendous savings as you go from one process technology to the next. And then the other thing, which is not to be understated, is the importance of execution. Like, executing is really, really important. And this is a way in which different merchant silicon vendors, you know, succeed or fail and differentiate themselves, is how well they execute and how fast they can get their products out and with what success. So there are execution differences. But it's really these things. But the point is that there's really no fundamental advantage. There's no different magic that happens with custom or proprietary silicon. The fundamental limit, of course, is that silicon size is bounded, and you know this, and it's bounded by the reticle size and the feasible die size based on defect rates in silicon manufacturing processes and yields that prevents chips from getting too big. So there's a practical limit. And this is just like a physical thing, again, that everybody plays with. And so given that physical limit and the choice that everybody's got the same tools, choices are really driven by these trade-offs, as I said. And so you have choices when you're making merchant silicon about with the finite die area that you've got, about whether to allocate more of that space to ports. Do I add more ports? Do I add more lookup tables and get larger lookup tables, add more counters, more rewrite capabilities? Do I have more packet buffers on chip? Do I decide I need 32 megabytes or 128 megabytes or 64 megabytes in my chip? And then in terms of parallelism, determines how much parallelism I have in the chip, also determines the speed, like my packet rate. And how much logic I have factors into how programmable the chip is. So in order to have programmability, I have to have extra logic in there. And then I have two other sort of, you know, levers that I can pull on, which is die size, so I can make the chip bigger, but of course that adds cost. And then power factors in as well. So more pipelines can go faster, but it requires more power. Different devices make different trade-offs in this kind of multi-dimensional space. The industry is highly competitive here. There's a tremendous amount of innovation, which is really cool to work in this space and talk to the startups and talk to the companies about what they're doing. But like, this is true even within one vendor. Like, the different families within one vendor are competitive. And at Arista, we really evaluate all of the merchant silicon that's out there. Like, at all times, we're constantly talking to people and looking at them and looking at what they've got coming in order to build the best products across this range of choices. Okay, so that's merchant silicon. Now I want to talk a little bit about service provider networks and how merchant silicon intersects with some trends in service provider networks that I see. This is what I think is happening from talking to service providers. And so a first fact that I think is kind of undeniable is that service provider routing has evolved. Like, there is and was a very important legacy of service provider routing of 30 years of protocols and services and hundreds, thousands of like internet RFCs describing functionality. But there is a new world that's evolving where simple, fast, reliable service is increasingly important. And I think just a couple examples of it that I think Sham talked to are, in the commercial space, there was a lot about VPNs and high-touch services and tunnels and overlay networks provided by the service providers. Much of that is getting replaced by SD-WAN and activity happening at the edge and commercial services. Some fraction of that business is moving to customers who just want, give me a fast internet connection, that's what I want, and I'm going to build my own reliability on top of that. And the same is happening, a similar thing I think is happening in the residential service, where again, that's very competitive. The demand for bandwidth from Netflix and Hulu and whatnot is like, and YouTube is just insatiable for like over-the-top video. And so competing in the service provider world in residential service, like what can I do? Well, I can drive up the bandwidth and I can make it really reliable and cheap to operate. And that's simple and fast. And we see those same trends not just in the data plane, but also in the protocol level. And Sham talked about this, and Alex will talk more about this as well. But like EVPN and segment routing have become tools that have allowed service providers to simplify their network. And it's not slicing and dicing the bandwidth anymore. It's about providing reliable, high-speed bandwidth. And this, we still need to support the legacy where it's necessary, but and it is important, and I don't want to dismiss the fact that there are lots of protocols and there's a brownfield and service providers need that, but they also need to deliver the high bandwidth, simpler services. So a first trend that I think kind of comes out of this is just like going simple and fast when you can is cheaper, it's more reliable, and it's better. Again, when you can. Strategy around that is to simplify, improve your reliability, reduce your OpEx, enable high bandwidth. And where you can't simplify, you can simplify the underlying technology. You can simplify by automating. You make the solution simpler and easier to manage, the unavoidable complexity that you're stuck with, and the diversity of products and diversity of connectivity technologies and whatnot that you've got. Okay, so that was my first kind of trend. The second trend is that, or fact, I think, that again is undeniable, is that service providers have a lot of use cases. And it was very interesting. I was in a conference and I was talking to one of the guys who runs one of the largest US service providers, and he just impressed upon everyone, they have everything. They have every use case. They have every router that anyone makes, they have it somewhere in their network. And because they've got all these different use cases, from metro aggregation, business services, core routers that need high speed and traffic engineering, peering routers that are need lots of table scale, lots of peers, residential aggregation, which really just needs this high bandwidth functionality. They've got data centers with data center technology, possibly with service chaining layered on top of that, and VXLAN and MPLS may be running as part of that solution. They've got data center interconnect. They're interested in innovating in the optic space with ZR, VXLAN, EVPN. There's a ton of different use cases. Service providers might have all of the use cases that Arista sees. It's kind of amazing, and they're interesting to talk to. So a second trend that I think, again, if you map that onto merchant silicon, I think...
Excuse me, I have a question.
Yeah, go ahead.
Regarding your last slide,
sure.
Do you only have solutions for backhaul, or you also have something for front haul?
I think we have solutions. I think it's very specific what you need to front haul and back haul to a particular solution. I think we have solutions that are applicable to all of that. So I guess, I don't know if there is a solution for front haul or a solution for back haul. You have to look at a specific carrier, a specific service provider. But I think we have solutions in those spaces.
Okay, thank you.
Okay, sure. So I think that, mapping this onto merchant silicon, there are different use cases benefit from different silicon. And that's sort of not surprising, but it's true. And so as a service provider, I think what I see the customers who are, forward thinking in this space doing is they really want to use the best silicon for the role. You bring your Leatherman when you're don't care about the weight and it's more expensive, and you bring your Opinel when you're going backpacking, and you got the Machete when you just need to hack through bandwidth, and I need a lot of traffic sent fast, right? There's different silicon has different advantages. And at the same time, and maybe this is obvious, is that there really is no ideal silicon. you can build extremely flexible silicon, flexible packet processing with like arbitrary rewrites, unlimited lookups, trade-off, buffering for tables, for packets, for rewrites, but it's not free. Like, I don't bring this thing when I'm going backpacking because it weighs a ton, right? So you can build flexible silicon, and not that flexible silicon is not good. Like, flexibility is great when and where you need it, but you don't want to be tied into something. This is another trend that happens. Is like service providers, I think, well, customers in general, I think, are wary of being tied into something that only one silicon can do, that requires flexibility, that locks them into a single silicon or a single vendor. So it's not that there's not use cases where you need that, but there are trade-offs, and this sort of extreme flexibility is not free. So expanding on that, and stating what's perhaps obvious based on what I'm saying, is that merchant silicon enables our customers to choose trade-offs, depending on the use case, your core, your edge, your data center, your DCI, routing, etc. And so different families have different attributes. I'm not going to attempt to walk you through this graph of silicon families from different vendors, and this is my subjective assessment of what I think the strengths are and the grades that I would give them, sort of consumer report style. But I think that I think that the point I want to impress is that there are different trade-offs, and there's no one best silicon for every use case, but there are real advantages to using the best silicon for a particular use case.
Do you mind if I interrupt you for a question real quick? Because
sure.
I think your chart here outlines a question that I was going to ask you, but I said you were getting into it, so I didn't want to interrupt. But I work a lot in the disaggregated space with disaggregated operating systems, and so in the ODMs, use all of these chips in different, in different roles in the service provider, as you've outlined. And I guess one of the things that I wanted to ask you, and you've already stated it very clearly, so we're overstating the obvious, but we go into pretty epic debates about, commodity silicon and merchant silicon versus proprietary silicon, especially in the service provider space, because historically, we haven't had deep buffers if you want to do 100 gig, 400 gig long haul. And there's been all these, it was designed for the data center. And then, we haven't had it until maybe last 2, 3, 4 years. So, how do you see that changing? Because obviously Arista is leveraging merchant silicon, and they're doubling down on it, and we use it a lot as well. I see the future as very bright for service providers in merchant silicon, and I see, custom silicon maybe not going away, but certainly shrinking. What's your take on that for the future of that relationship?
I think your insight is right on. As a very, I think insightful comment, and I think it's all true. I agree with what you said, and I think that it is true that I think there was a shift in service providers' view on silicon, really kind of with the Jericho generation. So back in 2016-ish, and a little bit in 2013 with a rod, but it was really 2016 in the Jericho silicon, which had deep buffers, which they've historically had use cases where they needed that, and it could hold the full internet routing table, with lots of room to spare for V4 and V6. And I think it was the full internet routing table plus the deep buffers that opened up a lot of those customers' eyes to that, oh, I should be considering this. And wow, the pricing on this is fantastic. And so I really got to be looking at this. And I think it opened up their thinking to be, along the lines of, well, maybe I don't need, and in 2016, 2013, we didn't have every feature under the sun. That list that I threw up before, we didn't have that, right? It was really limited to, the old school router companies, right? So we didn't have that breadth of portfolio, but it was still the service providers and, content providers and, people doing, buying routers were oh, the economics of this are so compelling, I got to be using it. And I can make some compromises, I can change my network, I can simplify, and then I can use merchant silicon. And I think by simplifying, it also allows them, to go faster, which allows further simplification, actually. Speed simplifies. So I don't know if that's...
No, I would agree with that.
Yeah. So I think that's kind of the trend. And then, of course, what's happened to us is we've gotten pulled little by little into more and more service provider use case. Now we have a pretty full portfolio of that, brownfield, legacy stuff actually in Arista products, which is now part of EOS as one operating system. So actually like applies, not just to that one family of merchant silicon, although there's some component that does. And so like we've really focused on the Jericho silicon for those use cases.
Yeah, that makes sense. I'm excited to see Marvel in your portfolio as well, because I think Marvel's got a great play in building some inexpensive SP applications that you need to push out. I think they've got a good angle with their chipset, and I don't see it in as many vendors. So I'm glad to see Marvel in there.
Well, just to be honest, like we're not actually shipping products based on the Innovium silicon. We have used XPliant, and we've shipped products based on XPliant. I mean, this is the space. But we're evaluating everybody all the time, right? And trying to make sure that we're considering everything. And we talk to our customers, and like our customers and the service provider customers and the cloud customers are very aware of what's going on in the merchant silicon space, and they tell us what we want. And like we're like kind of coin operate at that level. Okay, you want that? We'll build it. Right? So another thing that merchant silicon enables is the scale of merchant silicon, because the global reach and like their investment and their savings across different families enables them to build kind of right-sized products even within a family. So like right now we're shipping and using 5 flavors of Jericho and 4 generations of Tomahawk, just to like talk about 2 families, and they're variants optimized for port speeds and amount of memory and whether it has encryption on chip and the number of SerDes. But this gives us kind of consistent products within a family that are right-sized and kind of cost and power optimized for our customers. So that's another important advantage of merchant silicon. So one thing that I want to talk about is our operating system. So as you probably know, we have one binary that runs across all of our products, and it's really key to our strategy. It results in a better outcome for our customers and for Arista. Having one operating system image really enhances our testing efficiency, because all the testing that we do applies to all of the products. I mean, it's not that there are no drivers, right? Like we have drivers, like Linux has drivers, right? You have like an Intel NIC, or you've got a Mellanox NIC, or you've got, whatever in Linux. But like all the testing of Linux, outside of that applies across all of the products. And that's true for us. And it helps us, the single operating system helps us get faster time to market and produce a more stable image. So, or more stable software. Which is super important. So I want to talk about...
Hey, Chris Givings here with a question before you move on there. Speaking of software QA, I know that EOS does have a container-based image, but I believe that that's behind a registration wall. Are there any thoughts of opening that up to just be something you can more freely access? Other vendors have started to kind of open up their demo images and things like that, so it's a lot easier to get to. I'd be curious if you had any thoughts on that.
It is useful. Like I have no doubt that it's useful, and I don't know if we've talked about licensing it at lower scale or licensing it in some way, but that could be useful. But it is an important part of testing, and our customers do use it for testing. So let me go on to just talk about this, and I want to talk about merchant silicon and sort of the software that comes with merchant silicon. So typically, and I think this is the way the merchant silicon vendors sort of envisioned things, and I think we've changed their view on this a little bit, but like they envision that you buy their chip and you get a prefab SDK, also reference designs for the hardware if you want it, their microcode, basically everything in a package. And then you deal with some interface that's like, please load this route, please send this route to this next hop, please create this tunnel. And it's kind of a black box with some basic debugging inside that software development kit shell that isn't really that easy to optimize, because it's a bunch of code that you didn't write. And the result is kind of vanilla products. And what we found, and not to throw shade at like our partners, but like we found that like it hasn't scaled that well, and the control plane performance wasn't that great, and it was hard to debug, and it like honestly wasn't that reliable. And we sort of realized this through experience after shipping, a couple years of merchant silicon products in the early life of the company, that if we were going to get to that like internet scale, we needed to rethink how we were going to do our software stack. And so starting in like 2010 with a ROD generation that was going to have way more routes in it, we're like, we got to do this differently. And we went to our partners and got all the information we could get about the chips, leverage our expertise to build an optimized pipeline, and to build a software stack that did as much of what the SDK does as we could and lifted that out of the software development kit into shared libraries that are used across all of our products. And that is just like super duper valuable for us because we get better testing, better quality, we move faster. You know, the library that programs the routing table on Tomahawk, on Trident, on Xpliant, even though the registers are different and the details of the table are the same, like the optimizations, the interaction with EOS, the data movement of the routing table, the restart handling cases, like those can all be common cases, and it's much better. We can have way more resources on it if we lift that code out of the chip-specific teams, which are much smaller, into shared infrastructure that's part of EOS. And that way we get better testing, better optimization, more people we're able to dedicate to working on it, and a better result. And it helps us to ship the silicon on the first day it's ready, which is really, really important. Because of that up and to the right curve, getting to new silicon is super duper important. This is my final slide here. So like merchant silicon and Arista, here's our strategy in a nutshell. Okay, the underlying fact is like Moore's law is charging along. Like TSMC has announced 2 nanometer process in 2025. Merchant silicon is kind of 3 years behind the cutting edge of TSMC. So like we have like a roadmap out to like 2028 or something. And there are huge power, functionality, cost, density benefits by moving to new chips. And we want to have broad silicon choices, simple and fast options to benefit service providers. And our strategy is really to optimize the software for time to market with functionality. It's got to be ready to go as soon as that silicon is ready, but with functionality that the service providers need. And also number one always, as I'm sure you know, is quality at Arista. So like we have to develop a software stack that can deliver that functionality as quickly as possible with the quality that our customers have come to expect and really they depend on to operate their networks and their businesses.